Welcome again to my video tutorial. Till now, I have discussed basics of number system, algebra and percentages. Now I will discuss another basic topic, averages. You all must be aware of averages and its uses. In this lecture, we will study some basic properties of averages followed by level 1 and level 2 difficulty exam questions. If you are expert in framing equation, you can easily excel averages with simple basic formula. So to discuss averages in detail, let's go to our class. Welcome again to classroom. Today I'll discuss averages. You all would be familiar with the term average. Average is basically mean value, and the basic formula of average is sum of all observations upon total number of observations. This formula can be represented in many ways. Like I can write it as sum of all quantities upon total number of quantities. Okay, to understand this formula and how this formula is applied on the questions and to know general properties of averages, let's take an example. A civil engineer Raman goes to doctor for some health issue. Doctor prescribed him a liquid medicine which he has to take for 4 days. On first day, he has to consume 150 ml of liquid. On second day, he has to consume 50 ml of liquid. On third day, 100 ml, and on fourth day, he has to consume 80 ml of liquid. Our question is, we have to find the average volume of liquid which he has to consume per day. I think you have understood the question. These are the medicines which Raman consume on different days. On the first day consume 150 ml, on second day consume 50 ml, on third day consume 100 ml, on the fourth day consume 80 ml. We have to find the average consumption per day. For the average we have the formula sum of all the observation upon total number of observation. Here sum of observation will be 150 plus 50 plus 100 upon plus 80. Okay, upon total number of observation. Total number of observation is 4. So I am solving it. Average is equal to 150 plus 50 plus 100 plus 80 upon of 4. If I solve it will come out to be 380 by 4. And if I simplify it, it will come out to be 95 ml. Hence the average consumption per day of Raman is 95 ml. Okay, this is a theoretical answer. This is a theoretical average which I have got. Let's go to a practical room to see the physical significance of the averages and to understand the basic properties of averages. Here I have liquids which Raman consumes on different days. In the first glass I have the liquid medicine of 150 ml which Raman consumed on first day. In the second glass I have 50 ml of liquid which Raman consumed on second day. In the third glass I have 100 ml of liquid which Raman consumed on third day. And in the fourth one I have 80 ml of liquid which Raman consumed on the fourth day. If we have calculated the average for this all liquid, because we needed to find the liquid which Raman consumed per day on an average, so we calculated average for this. So in order to calculate average, we have added all the volume of liquids and divided it by the total number of observation. And here total number of observation was 4 and sum of the liquid was 380. So we have divided 380 by 4 to get the desired average. That was a theoretical part. To get some observation, I have taken this practical experiment. So I'll just add up the volume of the liquids available with me. For adding up the liquids, I have one beaker, I have one jug in which I'll add up all the liquids here. From the first liquid, I'm adding 150 ml of the liquid in this jug. Then again 50 ml of the liquids. Then again 100 ml of liquid. Then 80 ml of liquid. This is the sum of observations which I have got by adding all the liquids, that is 150 ml plus 50 plus 100 plus 80 ml, that means 380 ml. This is the sum of the observations which I got after adding up all the liquids. In order to calculate average, I have divided this sum of observations by 4 because there are 4 observations, 4 number of days over there. So I divided it with 4 and I got the average to be 95. Okay, for differentiating 95 volume from this, I have one more glass of 95 ml. I'll take out 95 ml in this glass which is average. I have taken 95 ml of liquid in this glass from this jug and I am redistributing it again in these glasses. I have added 95 ml of liquid in this glass and again 95 ml of liquid the second glass. Again 95 ml in the third glass. Again 95 ml in the last fourth glass. After distributing all the liquids, I have no liquid left in this, either in jug or in this glass. That means all the liquids which I took from this glasses are now redistributed in this glass again. So the observation which you need to note from this observation is that all the liquids which I collected from the different glasses are now redistributed and the quantity are equal in all the glasses and their quantity is 95 ml, which is the average value. So hence I can interpret average redistribute the sum of observations to all the observations equally. That means 95, 95, 95. This is the first thing we should note regarding average. And the second thing we should note is earlier in this glass 150 ml of liquid was there. Now there is 95 ml of liquid. Therefore I can say some amount of liquid has been decreased, and in the second I can say there was 50 ml of liquid here. Now it has been increased to 95. That means some of the amount of liquid has increased. In this the liquid was decreased, in this some liquid has increased. So I can say in all the glasses either there is some increment or decrement. But the thing we should conclude is all the increment and decrement are from the total amount of the liquids we were available with. We have not added any liquid from outside, we have not thrown any liquid, all the liquids are redistributed. So if there is some increment or decrement, they are just with that sum of liquids available with us. So I think this point is clear to you. For discussion on some properties of averages, let's move to classroom again. Let's discuss some properties of averages. First property is average distributes sum of observations equally to all the observations. And the example we have taken just now, in that we had observations in which we had 150 ml of a liquid in first glass, and then 50 ml of liquid in the second glass, then 100 ml of liquid in the third glass, and then 80 ml of liquid in the fourth glass. And the average of this set of number was 95. Okay, the average of this set of number was 95. And when I have redistributed this 95 ml of liquid in all the glasses, it was distributed equally and no other liquid was left. This property says the same thing. Okay, I think this property is clear to you. This property helps to solve questions. Sometimes it's easier to solve the questions with this property only. Okay, so I have taken this property. Now I'm moving to the second property. The net deficit due to the numbers below the average always equals the net surplus due to the numbers above average. Question says, suppose in this particular example, this says if I just subtract 150 from then 95 from 150, I'll get a difference amount of 55. Okay, this is the surplus amount. Okay, this is a surplus amount, and so I have taken here positive sign. If I just to subtract 50 from no, sorry 95 from 50, I'll get some deficit amount. That means of 45 minus 45, it's a deficit amount. That's why I've taken minus 45, because here number has the quantity of liquid has decreased, and in this the quantity of a liquid has increased. So I've taken here deficit amount. Okay, and in this it's a surplus amount of 5 ml, and in this that was a deficient amount, it was minus 15. And when we calculate the net deficit, that means minus 45 and minus 15, it will come out to be 60. Net deficit is 60, and if I calculate net surplus, which will come out to be 55 plus 5, okay, which is 60. That means net surplus is always equal to net deficit. This point says this thing. Okay, one thing you should also note, that if I add all the deficit and surplus amount, I'll get equal. It will be equal to 0. Okay, this point should be clear. And this logic, this property is sometimes used for solving questions also. So I've taken this point. I think this point is clear to you now. Now moving to the third point. The third point is the average always lies above the lowest number of the set and below the highest number of the set. Okay. The third point says that suppose in this particular set 150, 50, 100 and 80, average will always lie between the highest of the number, here highest number is 150, and between the lowest, and between highest and the lowest, it is lowest is 50 here. In this set 150, 50, 100 and 80, lowest is 50. So the average will always lie between 50 and 150. So here average was 95, that means average was lying between 50 and 150. This third point says this. Okay, this third point is used in solving questions on allegations. Okay, and this property is also sometimes used for hit and trial funda also. Okay, suppose I am re-explaining with some other example also. Is 1005, 1408, 1480 and 432 is set of a number. If I ask you the average will always lie between 432 and 1480, because highest in this number is this and the lowest in this is this. So average will always lie between this number. I think all 3 points are clear. There are some other properties of averages also, but that are not so important as per the exams are concerned. So I have taken these 3 points only, and these are enough for exams. Now I'll move to some basic section. Let's see some basic concepts on averages. Here I have taken arithmetic concepts on arithmetic operations on all the terms of averages. Okay, our first concept says if each quantity is increased / decreased by a certain value k, then average is also increased / decreased by k. This says that, suppose for example, if there are 3 terms x, y, z, and I have to calculate its average, it will come out to be x plus y plus z upon 3. Okay, this is the average. This property says if each term of the observation is increased by k, that means each term is now k, y plus k, z plus k, and this is, then the new average will be a1, and it's according to the basic formula, its value will be sum of observation upon total number of observation. Here total number of observation is 3, not 6. Don't be confused, because these are single term. Okay. Here the new average will be like this, and if I simplify it, it will come out to be like this: x plus y plus z upon 3 plus of k. Because if I simplify it, it will come out like this: x plus y plus z plus 3k, and 3k divided by 3, which will be k only. Okay, so this is the new average, and I know the value of this value, this term is a. So a1 will be equal to a plus k. So hence this property says that if each term of the observation is increased by value k, then average is also increased by k. This concept is valid on subtraction form also. That means if I subtract k from all the terms of the observation, okay, then the average is also decreased by that k. And this is also valid for multiplication and division. The second concept says the same thing. The second concept is, if each quantity is multiplied slash divided by a certain value k, then average is also multiplied divided by k. I think you can easily solve for this concept. Okay, you can frame example for that also. Here I have taken 3 terms. There can be any term. There can be more than 3 terms, n terms, any terms. Okay, this concept is valid for all the terms. So I think this concept is clear to you now. Now I move to the second basic method, that is false assumption method, which is used in data interpretation section for calculation of averages of higher numbers. Let's see another basic topic, that is false assumption method. False assumption method is not so important, so you can skip this section also. This false assumption method is used for calculating averages of higher number. This is basically used in data interpretation section. Okay, here I have set of number and I have to calculate the average of this number. I am solving it by false assumption method. However, you can solve it by basic method, that is sum of all the observation divided by total number of observation. You can also solve this question by that also, but I am solving this question by false assumption method. In false assumption method, we basically assume the averages. And how we assume the average? We must first check out which is the lowest number in the observation. In this observation, lowest number is 1390. That means this number is the lowest. And then we check which is the highest number, and the highest number is 1970. Okay. Then we assume our average in between them. Okay. So here I am assuming my average to be 1500. This is the assumption. Okay. This is the assumption that our average can be 1500. And now after assuming, we start solving this question. Okay. After assuming, subtract 1500 from all the terms. So I'll subtract 1500 from all the terms. When I'll subtract 1500 from 1480, I'll get minus 20. When I'll subtract 1500 from 1970, I'll get minus 470. When I'll subtract from 1600, I'll get, sorry, this time will be positive because 1970 minus 1500 will give me positive sign. So this sign is, in false assumption method, sign is very important. So always focus on sign. Okay. When I subtract 1500 from 1640, I'll get 140. Okay. When I subtract 1500 from 1390, I'll get 110. This time negative because 1390 minus 1500 is minus 110. And you can also term it as a net deficit and net surplus. And now in the second step, the next step, you just need to add up the things with same sign. Here 417, 140 are positive signs, so I'll add up them. If I add it, it will come out to be 610. 470 plus 140 will give me 610. And I'll subtract the things which are in negative sign. Okay, here negative sign is 130. Okay, so I'll solve it. Then I'll subtract it. It will come out to be 480. Here 480 is positive. We should note this. It may be negative also. Okay. Then after, in the next step, divide 480 by total number of observation. Here total number of observation is 1, 2, 3, 4. That is 4. So I am dividing it by 4. 480 divided by 4 will give me 120. Okay. 120 what? 120 of positive sign. This point should be noted because if negative sign will be there, answer would be different. If positive sign is there, answer would be different. Okay. I have got positive 120. So that means I have to add 120 with to the average which I have assumed. I have assumed the average to be 1500. Now I have to add 120 to get the actual average. So the actual average will be 1620. Okay. If there would have been negative sign, I would have got negative sign. I would have subtracted from it. But here I have got positive sign, so I'll add it. And one thing you should also note, if I would have added this all and have solved it with the basic method, okay, I have calculated the average of this with basic method, I would have got the same answer. But in false assumption method, the questions is reduces to the lower number. Okay, that's why this method is useful in DI section. So I think this is sufficient. Now I'll move to one more basic topic, which is weighted average.